So we've covered the basic idea of the product property. Now we want to do a couple of examples and also look at the quotient property. Okay, so we've already done a simple example. Let's look at another one. Let's take the square root of, let's throw some variables in now. So the square root of 9x to the third power. Okay, now I know that this can be rewritten as the square root of 9. Now here's the problem, is I've got an x to the third. Okay? I don't know what the square root of x to the third is, but I do know what the square root of x squared is, because I know that the squared and the root cancel out. And so I'm going to rewrite the x to the third as x squared times x. Now that shouldn't be too difficult to understand, right? Because we know that when we multiply variables, we're supposed to add the exponent. So the 2 plus the 1 would give me the 3. And so I've now written this in such a way that when I write it out, I've got the square root of 9 times the square root of x squared times the square root of x. And I can do this. I know the square root of 9 is 3. The square root of x squared is x, and then I'll be left with the square root of x. Okay, see how we did that one? If you wanted to do the tree here, you would just separate the 9 into 3 times 3, right? You would separate the x to the third into x times x times x, because that's what x to the third is. I've got a pair of 3's, so I'll write down the 3. I got a pair of x's, so I'll write down the x, and then I've got one x that's left over, and the leftover has to stay inside the square root. And so either way, I get exactly the same thing right there. Okay? Let's look at one more example. Okay, this one we're going to actually do a little bit of both ways. Okay? Let's take the square root of 21 x y squared, and now we're going to multiply this by 3 times the square root of x. Okay, now we're going to add in a couple of different concepts here. One idea is that when I multiply radicals, okay, when I multiply square roots, I'm going to multiply the things that are outside, and I'm going to multiply the things that are inside. Okay? So outside, I've got a 3, and basically this is a 1, because it's 1 square root of 21xy to the third. So I'll rewrite this as 3, and then I'll multiply the insides, and if I multiply x times this, then I'll have 21x squared, because x times x is x squared, y squared. Now some of you may be wondering, why didn't you FOIL or distribute or whatever? You only distribute if there's a plus or a minus in here, right? And there's not. This is all one term, so I only need to multiply the x by that one term one time. And so I've simplified it now, and so now I'm going to take the square root. 21 doesn't have a perfect square factor. If you do the tree, you'll notice that it's 3 times 7, and there's nothing else I can divide these into, which means that both of these will be left over. They'll both stay inside the square root. However, I can take the square root of x squared. Square root of x squared is x, and the square root of y squared is y. And so I can rewrite this as 3 times x, because I took the square root of the x squared, times y, because I took the square root of the y squared, and then the leftover inside, the thing that I didn't have any squares or pairs or anything, is the square root of 21. So hopefully that makes sense, and you can see how we took pieces out and we left other pieces in. Okay? What I would like to look at now is the quotient property. Okay? The quotient property of radicals is much like the product property. Okay? And I'm going to go ahead and write it out here. The quotient property of radicals. And the quotient property of radicals is just simply the same thing, except it works for division. if I've got the square root of two numbers being divided, that's the same thing as the individual square roots being divided. Okay, so if I've got one big square root, I can split it up into two smaller square roots. Sometimes that's helpful, and I'll show you a couple of examples why right here before we go on to our last video. So, for example, let's say that I had the square root of 13 over 100. Okay. Now, I have no idea what the square root of 13 over 100 is. Obviously, I could type it in my calculator. But if I'm just simplifying this by hand, then I can break this up now into two square roots. The square root of 13 and the square root of 100. Okay? Now, I don't know what the square root of 13 is. It's actually a prime number. I can't even simplify it as it is. So we're just going to leave it as the square root of 13. And then the square root of 100, well, I know that 10 times 10 is 100. And so the square root of 100 is 10. And so it's now been simplified. Now, if you didn't know that 10 times 10 was 100, then we just make our factor tree. We know that 2 times 50 is 100. 50 is 2 times 25. 25 is 5 times 5. So I've got a pair of 5s, which will come out. I've got a pair of 2s that will come out. So a 5 and a 2. 5 times 2 is 10. Okay. Now notice when we do these factor trees that we don't pay attention to the numbers in between. Once it's been split up, then we don't have to worry about it anymore. And so we just worry about the numbers that are at the ends of the branches. Okay. So there's your quick introduction to the quotient property of radicals. And so let's take just a minute and we'll go on to the next video.